to turn the spindle on. See this green button? Spindle gets turned on. Guess which button I hit to turn it off? Yeah. Remember that when you guys do your driver's test. Right? So, pretty simple, right? So which device do you think can cause you the most harm on this machine? Yeah, the revolving tool. Mounted into our spindle is a 3-inch fly cutter. Okay, see all those inserts? If your fingers or hands come in contact with them spinning at 1200 RPM, you're going to do some damage. So we keep our hands and our fingers away from the revolving tool. So when you guys are fly cutting, and all the mills right now have a fly cutter in it. This one's a 3-inch diameter, 1-inch diameter, 3-inch diameter. They may be different from machine to machine. But when you're fly cutting, you're going to be fly cutting in the x-axis. So once we position our tool properly, we want to lock in the Y. So the Y lock is right underneath our saddle right here. So if I'm cutting in the x-axis, we want to make sure these two locks are not engaged. They're loose. Okay? As the operator on the milling machine when you're fly cutting, we recommend you're standing right here. Because as that tool is turning in a clockwise motion and we take material off of our tags, we want to send the chips towards the column and put the pressure on our solid jaw, not on our movable jaw. Okay, these chips that are going to come off the machine are extremely hot. You get some of those chips landing on your bare skin, you're going to end up with burns. So we position our table and our cutter appropriately. Your Z-axis, we want to make sure, I'll show you guys right now. This is our spindle. Okay, they also refer to it as a quill hand. We want to make sure it's fully returned to the up position, and then our quill lock is engaged. Okay, that locks the spindle in place. We also want to take our depth stop and trap in the cutter. Then we take our lock nut and lock in the depth stop. Okay, so everything's returned up, everything's locked in, we don't run the risk of that moving on us. So when we take our depth of cut, we're using this handle that's on our knee. Okay, and that's our Z-axis. That sets our depth of cut. Okay, you guys with me so far? I know it's a lot of information. Biggest thing, make sure your locks are engaged on your Z-axis, everything's trapped up, and your cutter is turning in a clockwise direction when you turn the machine on. Okay, clockwise is to the right. Okay, everybody understand that? So, main work holding device, our vise. Solid jaw, movable jaw. Wrench. Okay, so to the left, loosey. To the right, tighty. Right? You guys understand that? Okay. So I got a very thin piece of steel. And I want to machine that material off as close to that layout line as possible. So I want to set it up in my vise so that it's higher than the top of the vise, so I'm not machining the vise, and I'm machining my workpiece. But the deeper you are in your vise, the more rigid or solid your setup is. Okay? When you're tightening the vise, so again, I want to take this wrench and turn it this way, to the right. You never want to push. If I slip, I'm putting my body parts into this steel. Okay? Potentially whacking my head off of this thing. It doesn't feel good. So you guys are good, big, strong, young teenagers. I put the handle in upright position, athletic stance, 2 hands on it, make sure my vise is tight. Okay? Whenever you finish tightening the vise, take the handle off and put it on the bench behind you. So next, my workpiece is mounted securely. I'm ready to turn my milling machine on. Green button. So using your x-axis hand wheel and your y-axis hand wheel, you're going to position your table so that it's directly underneath the cutter. The table moves, not the cutter, in the x and the y. Also, you want to offset your table so that we're directing the chips this way and putting pressure on the solid jaw. So I want to offset this roughly in a position like so. When I have the offset established, lock in your Y-axis. Now I can raise my table until it touches that cutter. I never want to ram the cutter into that, or never want to ram my workpiece into that cutter, because then you're going to smash all 5 of those carbide inserts. And it's about a $50 mistake. Okay, so take your time. You want to elevate your table until your workpiece touches that cutter. And you'll be able to hear it and feel it. So as I get close to the workpiece, I'm going to slow down on how fast I elevate it. Nice and slow and steady. You hear that? You can probably see it. So I touch my workpiece. I take my hands off the Z-axis. I bring my cutter back to what I consider my start position. This is when we set our depth of cut. You guys are just starting out on the milling machines, so I'm going to recommend that we start with 10 thou cuts. That's it. So, Z, green button. See how I changed my Z-axis to a 0? Now I can set my depth of cut. Anybody remember what 10 thou is in decimal form?
100.
Pardon me?
100.
No.
0.010.
0.010. Okay, 10 thou. So, looking at your readout. 10 thou. Now I'm ready to take my cut. I've locked in the Y-axis. Slow, steady feed rate in the X. I often will take this paintbrush, put it right here, because I don't want to eat any of those chips. I want to deflect them away from me. So as you can see by me setting up the cutter in the right orientation, I'm putting the pressure on my solid jaw and directing the chips back here. So again, when you guys are doing the cutting, keep your hands and your fingers away from that thing. This is one of the few machines where I allow students to wear a shop coat. In case one of those hot chips lands on your bare skin, you don't burn yourself. There's all kinds of shop coats hanging up by our sink area. So basically what you want to do is machine this surface enough to get down to your scribe line. So I want you guys to start with 10 thou cuts. But I want to give you an example of what this machine is capable of. So you're going to watch the Z-axis as I elevate my depth of cut. What's my depth of cut?
0.1102.
Nope. I already took 10 thou off of it. Nope. Because I didn't zero up my readout. Remember I took that 10 thou cut?
0.1002.
Yeah. So I'm just taking a 100 thou cut. Okay, 100 thou is almost an eighth of an inch. Okay, lots of material. You'll notice when I take this cut, the sound's going to change. And the size of the chip's going to change substantially. So, do you think I want you taking 100 thou cuts? Not yet. That time's coming, but just not yet. But this is the machine we're going to use to take the material off your workpiece instead of using those files that would take you forever. And we got 6 milling machines that we can use. They all have fly cutters mounted to them. Any questions on the safe operating procedures of the milling machine? I'd like you guys to just start with 10 thou cuts.
Yeah, well, like on the different, yeah, on the spin or whatever, is it like a different kind of cut, it's a smaller cut or?
Generally, if it's a smaller cutter, you can increase your speeds. So right now we're running this 3-inch cutter at about 1200 RPM. This is only a 1-inch cutter. We could probably spin that about 1500 RPM. But your depth of cut, I want you guys to start with 10 thou cuts, so you get used to cutting the material. If you take a 100 thou cut, you run the risk of taking too much material off your workpiece. And with brass, we can't put on material. We can't put material back on. We can take more off, but we can't put back more back